guys, I have another video, part 2, and this time I wanted to actually cover something about like magnetic striping and the mid-Atlantic ridge. And I want to show you something pretty obvious about our planet that they just don't seem to know about. With plate tectonics, they have what they call magnetic striping, and they think that this is proof that there's seafloor spreading happening, and that this is basically the powerhouse of plate tectonics. But magnetic striping is really someone's interpretation of their data. They see north and south stripes running alongside the mid-Atlantic ridge, so immediately of course it's got to be plate tectonics. It's going to be support plate tectonics. Nothing else could possibly make those same patterns except for plate tectonics. But that's not really true. As a matter of fact, I don't know if you've ever seen their image of their magnetic striping, but it's not really clear cut. It's kind of blurry, actually. And like I said, it's their interpretation of the data, and they like to interpret everything as if plates exist. But I know just by looking at the surface features that these cross marks right here are not folding, they're not made by compression, they're simply made by turbulence from this spinning. And what I'm claiming is that this spins up to the north, and in doing so, this also, not only does this sit here when it's spinning, it sits everywhere here. That's the thing about this, is that these are reoccurring patterns, and this is the main image here. So basically this will be sitting in the middle of here. And when you think about it, this is what I'm claiming is spinning. Imagine if it's magnetic and it's spinning, you're gonna get striping like a barber pole. It's gonna be striping north and south as it's rotating, right? It's that easy, really. Let me show you my evidence, though, so you don't have to just take my word for it. Okay, here's the first one. What I did is I took a negative of this and then I flipped it around as if this was tumbling up. And in doing so, you can see that these are spaced apart about the same as this right here. So here it is flipped the other way. And then my proof is that when things line up, that's pretty solid. When you have alignments, then that means that it was there in that position. And like I said, it will cross too, because it's the same thing. It's just, it sits here or sits here, it doesn't matter. So you can see that this first one, it matches. It's just hard to see. These are complicated to see through, but like I said, anybody can try to discredit me. So you got that one right there, and when you move this up, you can see this feature right here fit right into here. More evidence supporting what I'm claiming, and you can see it skipped. So it must be like in the middle of like rotating, and then this is where it lands reversed. That's what I'm thinking. And then, you know what's funny is that when you look at this, you can see it. This lines up with the mid-Atlantic ridge again. Isn't that unusual? Well, I think that what the deal is that throws this whole thing off is that we're looking at images of a smaller planet. So it kind of, you're going to see stuff that's going to seem impossible, but that's only because you're not looking at it correctly. You're looking at it as a big, large planet, and it's actually a smaller. As a matter of fact, it could be about this size right here, this rounded area that's shaped like a football. But that's just speculation. And then you got to notice that there's a crisscross here in the imaging here. So that's going to be something too. But anyways, I want to show you the next step though here. What I'd like you to notice is that when you see this right here, you're actually looking at a triangle. I don't know if you can see it. The point would be right here, and you can see this is spinning over. This is going under, but the triangle that I'm looking at is, let's see, it's right here, something like that. Hold on, it goes like this. So there's a reason why I'm pointing this out. You'll also notice when you come up here to the North Pole area that there's another triangle here. And this one, you can see that it's like this. You can see the, I don't know, you should be able to see it. And this would be the point of it right here. I actually found this a long time ago, but I never really looked into it very far, but I knew it was going to be something important eventually. But yeah, here's a triangle shape, a long triangle. So here we go with our triangle here, and this triangle right here. You see that when I line it up, it actually makes sense. I mean, you can see it matching, and you can see this area right here. But what's cool about this is that you can move it around and you can actually see things happening when you zoom in. For instance, I can move this around, and I believe this is related to Iceland. As a matter of fact, you can see the lines. See how they match up? This is Antarctica. Here's Iceland. And you can tell that it's left marks behind right next to Antarctica. And in plate tectonics, there is no seafloor spreading north and south. It's all east and west. So what spread these areas apart if plate tectonics was accurate? See, this is the observable evidence that doesn't support plate tectonics. Plate tectonics doesn't get the choice of not acknowledging this. It has to. It has to have an answer for this, or it needs to be thrown out. Look at the alignment right here. It's solid, because this isn't the only marks left by Iceland. I'll show you more actually right here. And you can easily see how that fits. See how it keeps matching the same size? Slides all the way to Africa now. But that's actually not what I wanted to show you. I thought that was cool. So I show you this, but then remember I'm saying that this is flipping around. this around, this is actually what I get. I get this alignment right here. And you can tell that this is related because look at the matching right here. Look at the size. Look at how it keeps matching as it's sliding over. Actually right there you can see the Hudson Bay as it slides towards Florida, because this is also going to make Florida down there as it rotates around. But look, let's see here, right here. Okay, so this is the original alignment right here, but then you'll see that it aligns there again. This is how reoccurring patterns work, and see the matching. Iceland. Okay, so it jumps from here. Of course it goes right there, look. And then it gouges this area out right here. But I have to get straight on shots for that. And that's the other thing about this. Remember the twisting, and this is a breakage. This tells the story. This is only one part of the story. There's other areas around the planet that line up exactly with this, that look nothing like this, but they match perfect. It's over for plate tectonics. It has to be. Look at, as I bring this. Let's see here what I can do with this before I end this video. When you move this around, you see all kinds of stuff. When you do your own overlays, that's what I'm asking people to do, is their own overlays, so that they can see for themselves. None of my trolls ever do their own overlays, so they have no idea if I'm wrong or right. They just assume I'm wrong. But that's their mistake, because look at how it lines up here. Lines up all the way back over here. Remember, it was here. Lines up here. Did you see how it works though? Isn't that crazy? I mean, this is a scientist's wet dream actually, because these realigning like they do is amazing evidence. It can't be disputed. Look how you got the Great Lakes here. Well, you can start to see a relationship between the features here. The East Coast, look, with this discharge off of Africa. It couldn't be more obvious. And then you got the tip of Africa. What's the tip of Africa doing lining up here when it's all the way over there? Well, remember I said these are images of a smaller planet. So you're going to get weird stuff like this, where this lines up with this part of Africa, because at one point it was wrapped around a smaller planet. And it just makes it really weird to look at. But anyways, thanks for watching, guys. This is getting better. I just wanted to do something here for a video. Now, the other thing is, if I had more time, I could show you that these areas align with the overspill, and that plays in a whole new part to this, where you can actually see the fluid material running over these, and you can see how it lines up. It looks pretty cool, and that's what I'll show in my next video, is what it looks like to put the Himalayas over here, and those fit. And they claim that the Himalayas are made by a collision, but I can show you that the Himalayas match reoccurring images all over the planet easily. So anyways, thanks for watching. I hope you guys like this. I mean, just look at the alignments. Come on, where's the seafloor spreading that separates these guys, if that's what is happening? And also, these are opposite sides of the planet. How long does it take plate tectonics to move a continent from one side of the planet to the complete other side? And why does this match so perfect? Where's the erosion? If this is an old planet, like they claim, they claim it's 4.6 billion years old. Well, how can that be when I'm matching the opposite side of the planet with zero erosion? And no matter what their dating says, these will still line up tomorrow, perfect, and the next day, and the next day after that. So I think it's their dating process that's messed up, not the fact that these match up so good. You know what I'm saying? It's logical. Sometimes logic has to override mainstream science because they seem to lack it. And you can tell that this is going to flip around and match this. Anyways, thanks for watching.